Something strange is happening beyond our planet right now. Scientists have given this enigma a designation, 3I Atlas. Despite this official name, the reality is that we're still puzzling over its true nature and behavior. 3I Atlas defies easy explanation. Its appearance is unusual, its trajectory is peculiar, its composition is unlike what we typically encounter. And after all our observations of this celestial object, emerging evidence suggests it may have been observing Earth far longer than we've been watching it. Consider the latest photographs of 3I Atlas, taken by astronomers working in Namibia's isolated desert regions in southern Africa. This location already offers some of Earth's darkest skies, but these researchers timed their observations during a lunar eclipse. During this event, Earth's shadow prevented sunlight from illuminating the moon's surface, producing exceptionally dark conditions, the perfect scenario for obtaining the most detailed observations of deep space phenomena. With their equipment ready during this rare opportunity, the astronomers had countless celestial targets to choose from, yet they directed their lenses toward 3I Atlas. What appeared in their images left them stunned. The object was radiating an intense green luminescence against the darkness of space. Here's where things get puzzling. According to current understanding of 3I Atlas, this green coloration shouldn't be occurring. At least, no conventional explanation exists for this phenomenon at present. The leading hypothesis among the astronomical community characterizes 3I Atlas as a comet of interstellar origin. In basic terms, this would make it comparable to typical comets we observe traversing our cosmic neighborhood. Such objects typically display a prominent glowing cloud of particles and gases surrounding their core. This envelope is known as the coma. It features the characteristic sweeping, fan-like tail that comets are known for. What sets this particular comet apart is its origin. It traveled here from an entirely different stellar system, somewhere distant in our galaxy. Given this exotic background, some peculiarities are anticipated. However, 3I Atlas continues exhibiting behaviors that defy logical explanation. Take the green coloration, for instance. Interestingly enough, comets displaying green hues aren't particularly rare. Since this is a well-documented occurrence, scientists have a solid grasp of the chemistry behind it. The green emerges when carbon-based molecules within the coma interact with the sun's ultraviolet rays. More precisely, this reaction involves diatomic carbon, designated as C2, which consists of a pair of carbon atoms joined together in a molecular bond. In a typical comet scenario, 3I Atlas would possess abundant quantities of these carbon structures across its exterior, causing it to emit that green glow when bathed in solar light. Yet comprehensive observations conducted throughout the summer months, utilizing virtually every significant telescope available worldwide, revealed something unexpected. 3I Atlas shows a notable absence of these carbon chain molecules. C2 is essentially missing from its composition. And yet, the green luminescence is undeniably present. What's causing this phenomenon? The answer remains elusive. Could it be extraterrestrial involvement? Perhaps they have a preference for green illumination. What we have confirmed is that 3I Atlas's coma contains substantial amounts of CO2, carbon dioxide, where carbon links with oxygen atoms. This is fundamentally distinct from C2. While this composition does account for the object's remarkable brightness, it cannot explain the green coloration. The sheer quantity of CO2 present is itself an anomaly, as it dramatically exceeds the H2O, or water vapor, detected in the coma. This ratio is essentially inverted compared to standard comets, which normally contain significantly higher concentrations of water relative to carbon dioxide. But the peculiarities of 3I Atlas's coma don't stop there. It's also saturated with metallic elements, nickel in particular. Now, finding metal in comets isn't inherently abnormal, but the timing and location of this metallic presence in 3I Atlas is perplexing. Many comets do contain metals in their makeup, And these metals can indeed vaporize and disperse into the coma, but there's a catch. This evaporation process only occurs under extreme proximity to the sun, where temperatures reach levels sufficient to turn solid metal into gas. 3I Atlas, however, isn't anywhere near the sun. In fact, astronomers first identified the nickel signature while the object was still positioned in the orbital region between Mars and Jupiter. There's no conventional scientific rationale for why it's ejecting metallic material, particularly nickel, at this distance. Unless, of course, you're willing to consider the possibility that 3I Atlas might be an extraterrestrial vessel. It's worth noting that rocket propulsion systems are commonly constructed from nickel-rich metal alloys. When these engines fire, significant amounts of nickel typically appear in the expelled gases. Carbon dioxide emerges in the exhaust as well. Naturally, an alien origin is highly improbable, yet there's another curious aspect to how 3I Atlas is navigating through our solar system, likely unconnected to any hypothetical propulsion systems, real or imagined. What stands out is the remarkable consistency of 3I Atlas's path and speed throughout our entire observation period. From its initial detection in early May through the present time in October, the object has maintained an extraordinarily stable course. No significant acceleration, deceleration, or directional shifts have been recorded. This may seem unremarkable at first, but for a comet, such stability is actually quite bizarre. Consider the typical behavior. As comets draw nearer to the sun, rising temperatures cause their icy material to sublimate. That's the process where solid matter transforms directly into gas, bypassing the liquid phase entirely. This outgassing effectively acts like a propulsion system, nudging the comet in various directions. Standard comets exhibit noticeable changes in both speed and heading based on which portions of their surface face the sun at any given moment. Astronomers refer to these shifts as non-gravitational acceleration, abbreviated as NGA. The measurement involves tracking the average positional deviation that accumulates over a 24-hour period. As documented, 3I Atlas has been actively sublimating for some time. Evidence includes a small tail structure that initially pointed towards the sun, which has since developed into an extended tail oriented in the opposite direction, away from our star. Despite all this outgassing activity, 3I Atlas's speed and path have varied by merely approximately 1.5 kilometers of NGA daily. For perspective, consider 2I Borisov, the most conventional member of the interstellar trio. Its fluctuations exceeded 100 kilometers daily, roughly 100 times the movement exhibited by Atlas. One might argue that Atlas simply possesses greater mass, making it more resistant to these forces. That's a reasonable hypothesis. However, let's introduce another comparison point: Comet Hale-Bopp. This is among the largest comets ever observed within our solar system, at minimum comparable in size to 3I Atlas, potentially considerably larger. Hale-Bopp demonstrated average NGA variations exceeding 10 kilometers per day. Once again, approximately tenfold greater than Atlas. Then there's Oumuamua, which surpasses them all. At certain junctures, its directional changes reached over 1,000 kilometers daily. When positioned alongside other interstellar visitors, 3I Atlas's motion pattern appears profoundly unusual. It maintains such an abnormally consistent trajectory that one could characterize it as deliberate, almost as though something is steering it through our solar system with purpose. A natural phenomenon likely accounts for this behavior, but let's entertain a hypothetical. If 3I Atlas were indeed a controlled craft, it wouldn't just maintain a fixed path. It could theoretically alter its trajectory at will. Current projections suggest that 3I Atlas will traverse the inner solar system on the sun's far side, relative to Earth's position. This means we'll miss any opportunity for close observation, and likewise, it won't pass near our planet, unless somehow 3I Atlas manages to decelerate during its solar approach, positioning itself to encounter us on the sun's opposite side. Here's a fascinating hypothesis that might have some credibility. Are you familiar with the WOW signal? Back in 1977, researchers at Ohio State University made a discovery using the Big Ear radio telescope, essentially a massive listening device designed to detect anomalous signals from deep space. On one particular occasion, the instrument captured something so extraordinary that the scientist analyzing the data scribbled OW directly onto the printed readout. That spontaneous exclamation became the signal's permanent designation. What left them astounded was an extraordinarily intense, narrowband radio transmission that persisted for 72 seconds, emanating from somewhere in the depths of space. The source was definitively ruled out as any human-made technology. It wasn't generated by our sun or any body within our solar system. The only certain information is that it arrived from somewhere in the region of the Sagittarius constellation. The most striking aspect of the WOW signal is the staggering power output that would be necessary to project a focused radio frequency across the vast distances between star systems. If this were the work of an intelligent extraterrestrial civilization, their technological capabilities would need to be so sophisticated that they could capture and utilize stellar energy on a massive scale. Alternatively, if natural forces were responsible, it would require some form of energetic process occurring within a star's interior. The second crucial element of the WOW signal involves hydrogen, the universe's most prevalent element. There exists what scientists call the hydrogen line, a specific radio frequency produced by hydrogen atoms. That's an oversimplified explanation, but the essential detail is this. The hydrogen line operates at a frequency of 1,420 megahertz. The WOW signal's frequency, also 1,420 megahertz. If an advanced civilization wanted to broadcast a basic yet unmistakable message across the galaxy, one that any scientifically knowledgeable society would instantly recognize, this would be the logical approach. Remarkably, in the 50 years that have followed, no other radio transmission remotely similar to this one has ever been detected again. Now here's where things get intriguing. Astronomers have successfully traced back 3I Atlas's path through space, and their calculations indicate it also originated from the vicinity of Sagittarius, the same general celestial region from which the WOW signal arrived. That's quite a remarkable correlation, and it's prompted speculation among some researchers that perhaps the WOW signal's true source wasn't a faraway stellar object at all. Instead, it might have originated from our current visitor, 3I Atlas, which back in 1977 would have been positioned at the solar system's distant periphery, well past Pluto's orbital path. Perhaps it was simply announcing its impending arrival. Naturally, this remains purely speculative, a hypothesis lacking concrete proof, and one that may forever remain unverified. Yet it's equally important to note that it hasn't been definitively disproven either. This uncertainty is perhaps the most significant takeaway as our understanding of 3I Atlas continues to develop. Phenomena like this challenge us to maintain intellectual flexibility when confronting the infinite mysteries the cosmos presents, whatever the reality may be it's currently traveling toward us.